So in this lesson, what we're going to do is we're going to use quadratic functions to help us solve some different types of word problems. Um, we'll start off with just a kind of a number word problem, but then you see here we have some applications of height, and that's when a ball is thrown or some type of projectile. We have profit, how much a company can make if they tweak things and sell more of this or raise a different price, and then cost. Um, so what we're going to do is we're going to be using quadratic functions, which means we're going to use, we can use the graph of the function. And as we think about the graph of quadratic functions, and we'll see this a little bit later more than on the first, well, on all of them, when you have a quadratic function, it's a parabola, and this parabola, all these points on the parabola represent things that make the equation, the function, true. And so if we picked this point, if this was 3, 19, that means when x is 3, y is 19. And there's all types of values along here. And for a parabola, you definitely have a minimum value for this parabola facing or opening upward. There'll be other times we have parabolas that open downward, and those parabolas have a maximum. And that's really what we're going to be looking at today, since you see this maximum, maximum, minimum. In this one, it talks about a minimum. So whenever we have these problems, we're actually going to be looking at the graph of the parabola and finding the maximum or minimum point, and then we'll have to interpret what that means in terms of the question or the situation that we're working with. So this first one, it says find two numbers whose difference is 6 and whose product is minimum. Now, at first thought, we might think difference is 6, we'll just do x minus y, but we really just want one variable. So there's a couple different ways you can do this, so I'll talk through one way. Another way would work just as well. But when you have two numbers whose difference is 6, that means they're numbers that are 6 apart, like 4 and 10. That's their difference is 6. So what you could do, one way to do this, is to let x equal the smaller number, because if there's a difference of 6, there's definitely one that's smaller. And so if you think through that, our larger number, we want it to be a difference of 6. Our larger number is going to be x plus 6. Another way would have to be one of them's x and the other one's x minus 6. Both of them would have worked out just fine. So we have two numbers whose difference is 6. So like, just for example, 1 and 7, their difference is 6, 2 and 8, 3 and 9. And then what we want to think is we want a product is minimum. So the product is multiplying them together. So we would think, okay, our different 7, 16, 27, those are our different products. So what we want to do, and since we're using quadratic functions, we want to come up with a function for this product. So I'm going to put p of x, and I'm using p for product. The product of the two numbers is x times x plus 6, which if we multiply this out, we get x squared plus 6x. And so our product is always going to be x squared plus 6x, which we realize since it's an x squared, it's a parabola, so this will have a minimum. And that's what we want. So what we want to do here is we want to figure out what this parabola looks like and find the minimum. Now we know the minimum is at the vertex, so we don't actually need to graph it. We can put this in work form, which actually we can do that here. So in order to put it in work form, we are going to take, we don't have to do a lot with this one. This is a simpler one. We can take half of 6, which is 3, and square it. So we're adding 3 squared, which is 9. So we also have to subtract 9. So we're really just adding nothing on that side. And so looking at this part, we have x plus 3 squared minus 9. And by looking at that, we know this is shifted to the left 3 and down 9. So the vertex is at -3, -9. So I will sketch the graph just to show you. So -3, -9 is going to be somewhere around here. And that is our lowest product. All these points along here, if we pick this point and multiplied whatever number this is times the number 6 more than it, it would give us a product. But this is going to give us our minimum product. And now this is our x-axis, and this is our p of x-axis. So this part right here really gives us more information than what this is actually asking for. So x equals -3, which goes back up, and we realize that's our smaller number. And so our larger number is -3 plus 6, x plus 6, which is 3. And so our two numbers, so find the two numbers, so the answer is -3 and 3. That's our answer, but I want you to notice something here, that what's the product of these two numbers? -3 times 3 is -9, which is right here. So this actually tells us what that minimum product is, because this is our p of x-axis, and that tells us what the product is. It's -9. So the answer here is -3 and 3. If it actually asked for the minimum, it would have been -9. Here's the next one. This one has to do with projectiles. In this case, it's an arrow. So some problems will give you the equation. All you need to do is put it in work form and interpret the results, and that's what we're going to do here. So we have an arrow is shot straight up with an initial velocity of 320 feet per second. This is a physics type problem, so disregarding air resistance or friction, the motion of the arrow is given by this equation, where x is the time that goes by in seconds, and h of x is the height of the arrow. So this is saying the height of the arrow depends on how long it's in the air, the time. What's the maximum height, and how long will it take to get there? Well, this is a parabola, and this parabola will give us the height. So I'll put in an x value, it will give us the height. Well, we want the highest height, so we're going to find the vertex of this parabola. So what we're going to do is we're going to do h of x equals -16x squared plus 320. We're going to put this in work form. So this is good practice for completing the square. We're going to factor out a -16. We have x squared. We can think, what's 320 divided by -16? And that's going to be -20. We're going to close our parentheses here, and then we're going to think, okay, now I'm going to complete the square. Half of -20 is -10. So I'm going to add -10 squared. Well, -10 squared is 100, but it's also multiplied by -16. So 100 times -16 is a -1600. So I'm adding a -1600. So to keep this being like adding 0, I'm going to add 1600 out here. And now I have completed my square. This is -16 x minus 10 squared plus 1600. And this vertex, because that's the point we're going to be interested in, because that's going to be our maximum. We know it's a maximum because this is opening downward because of this negative, so it's going to have a maximum instead of a minimum. The vertex is at 10, 1600. This is our x value, and this is our h of x value. So this vertex right here really answers our question. It says, what is the maximum height? Well, this 1600 is the maximum height. And what's the time it takes to get there? So this is 1600 feet, I believe this is in. And the time that it takes to get there is our x value, because x is the time in seconds, and we see at the vertex it's at 10 seconds, so 10 seconds. If we wanted to, we could sketch a graph. We're not going to write up to 1600, but we get an idea of what this looks like. So if this is 10 seconds, we'll say just this is 1600. This is going to be a parabola opening downward. And so we have all these different heights along here. It gets its absolute highest at 10 seconds, and it reaches 1600 feet. You don't need the parabola. That was just to show you. The next one here is one, and actually the example after this is similar with a little bit of a change, but this says Dylan is using 92 feet of fence to fence in all sides of a dog pen. What dimension should he use to give the dog maximum area? Let's just take a look at this problem first of all. So we can make lots of different shape fences. Or different size. It's going to be rectangular, all four sides of a dog pen. So here's what it's going to look like. So it could look like this, where so you have to use up 92 feet, and so you use up some for the width and some for the height, and so you could do different things there, and you actually could test this out and do different numbers. Let's say we pick 10 feet here, which this would be 10, and we could think, okay, we have 92 total minus 20 is 72, and that 72 divided by 2 is going to be 36 and 36. So this would give area of 360 feet squared. Maybe we could make this something like 15 and 15, which is 30, so we could do 92 minus 30, which is 62. Dividing that by 2 is 31. And so we could do 31 times 15, and that would give us that area. And so we want to maximize the area. We could do this by hand and keep guessing and checking and figure out the best area. But also what we can do here is we can think, okay, if we have a rectangle and we have a length and a width, we know that the area is length times width. So what I'm going to do is I'm going to let our width be x. So let x equal the width. Our length then, we have to figure out our length. Well, we have a total of 92 feet for around this whole thing. We're already using up 2x of it. So actually even better yet, let's talk about it this way. Here's one side and here's another side, and that's using up half of our fencing. That's half our fencing. Half our fencing is 92 divided by 2. So 92 divided by 2 is 46. So if this part right here is 46 feet, how much is here? Well, we would take 46, the total of these two, subtract x, and that would leave us with our length. So we would have 46 minus x for our length. And now what we want to do is we want to find the area in terms of x. Area in terms of x. Area is length times width, so our length is 46 minus x times our width, which is x. And now we'll multiply this out, and we realize we have a quadratic function. So this is 46x minus x squared. We usually like to put this in what we call descending order, where we put the highest term first. So this is negative x squared plus 46x. And now what we're going to do is we're going to complete the square to find the parabola. This is going to be a parabola that opens downward because it's negative, and so since it opens downward, it's going to have a maximum, and that's going to be our maximum area, and it's actually going to give the x value that we'll need. And so we remember to complete the square we need to factor out this negative. So this would be minus 46x. We'll put parentheses here because we're going to complete our square. We take half of 46, negative 46, which is negative 23 squared. negative 23 squared ends up being 529. So this is 529, but we have a negative out here, so it's really negative 529, so we have to add 529. And so now that we've completed the square, we have a function that is negative x minus 23 squared plus 529. Well, for our parabola, that means we'll have a vertex at 23, 529. So this is our x value, and this is our area. So our maximum area is 529 feet squared. Our x value is 23. That means our width is 23. Our length is 46 minus x, so 46 minus 23, which is 23, which actually tells us this shape will be a square. And it didn't ask for the maximum area, but we know it, so let's write it. We know the maximum area is 529 feet squared. So we have a dog pen that's 23 by 23 feet. These little apostrophes represent feet.